Batteries and rocket fuel. What do they have in common? It turns out that they are both made using principles of electrochemistry. Now, what is electrochemistry? Basically, it's a field of chemistry that specializes in the relationship between electricity and chemical reactions. The two main reactions of electrochemistry are when certain chemical reactions create electricity and when electricity makes certain chemical reactions occur that wouldn't otherwise happen. The first main reaction, when chemical reactions create electricity, happens spontaneously, meaning that it can happen without external force. The second interaction, when chemical reactions that wouldn't happen otherwise are caused by electricity, by definition, needs an outside force to cause it to happen. One phrase you often hear in electrochemistry is redox reactions. But what does it mean? Redox reactions are when atoms exchange electrons, which can create or be caused by electricity. By definition, electricity is moving electrons, so when redox reactions occur, naturally, like the first main interaction, it creates electricity. Some chemical reactions don't want to occur, so external electricity is needed to make it happen. The term redox stands for reduction oxidation. Reduction means gain electrons and oxidation means lose electrons. A useful mnemonic to remember this is oil rig, which means oxidation is lose, reduction is gain. A classical example of chemical reactions producing electricity is a battery. Take the galvanic cell. On one side is zinc, and on the other is copper. The copper is in a solution of Cu2 plus cations. The zinc and copper, in this case, are called electrodes, which is defined as a conductor electrically connecting with a non-metal part of the circuit. The zinc oxidizes, losing electrons that can be flowed through the wire and to the copper. The electrons go to the Cu2 plus cations, which reduces into copper. The zinc electrode is called the anode because it oxidizes, and the copper electrode is called the cathode because it reduces. Using the electrons flowing through the wire, one could power a device. An example of the other main reaction, when chemical reactions require electricity to happen, is called electrolysis. Suppose you have your anode and cathode, in this case it doesn't matter what material they're made out of, and you place them in water. When electricity is run through the water, hydrogen is created at the cathode and oxygen is created at the anode. Hydrogen and oxygen don't spontaneously come from water normally, but they do when electricity is run through it. This is because the electrical current reduces the hydrogen in the water molecules. Oxygen has a much stronger pull on electrons than hydrogen does, so it keeps the electrons mostly to itself. Because of this, oxygen spontaneously giving up its electrons doesn't happen. Therefore, for this reaction to occur, outside energy in the form of electricity is needed. Oxygen and hydrogen are also the two components of rocket fuel, and they are made through electrolysis. That's it for this video. Thanks for watching, and I'll see you in the next one.